Hi everyone. We have a problem here from mechanics, A-level mechanics. We are given this acceleration time graph and they want us to describe what a cyclist is doing during this graph. We are going to describe the cyclist motion looking at the graph, and then we are asked to draw a velocity time graph to show the cyclist movement. You can see this A here means acceleration and this is time. Acceleration time graph. That's what we are doing. On this line here, the acceleration, we have 2 meters per second squared. Let's read the question. The acceleration time graph shows the motion of a cyclist. The cyclist starts from rest. Cyclist starts from rest and travels in one direction. Describe the motion of the cyclist. Draw a velocity time graph to show the cyclist movement. This is the acceleration time graph. We have a positive 2 here on the y-axis. We have a negative 1 here on the same y-axis. And then we have, you can see this thick line. This is the movement of the cyclist. 3 lines. Yeah? 1 here from 0 to 10. And you have another line here from 10 to 50, and then you have another line here from 50 to 70. Because this is positive from 0 to 2, that shows acceleration. The cyclist was accelerating. And because this one is positive, so it's negative, this line here is negative on the negative side of the y-axis, it shows deceleration. It's reducing the speed. Here he was increasing his speed. Now for 20 minutes, 50 to 70. For 20 seconds, he was reducing his speed. And from 10 to 50, we can see his motion was on the x-axis. So it means his acceleration here was constant. It was not accelerating. That's why his acceleration here is 0. So if they ask you to describe the cyclist's motion, that is what you have done. But because we got to draw a velocity time graph, which means we need numbers, we need calculation. So this description is better we do it with calculation. This is acceleration time graph. We now need a velocity time graph. This is, let me just put it this way. Velocity meters per second. This was meters per second squared. And time, t in seconds. Here we are told from 0 to 10, the cyclist accelerated to 2 meters per second squared in 10 seconds, 0 to 10 seconds. If you want to interpret this information from a velocity time graph point of view, what that is telling us is the gradient of the line, because here we are dealing with constant acceleration. So we've got straight lines. So the gradient of the line, you know, y all over x equals gradient. This is the gradient of a line. Yeah? The rise in y over the run on x is what we just interpreted. And that gradient and a velocity time graph is equals to acceleration. So what do we have here? We have here y all over in 10 seconds, accelerated. That is 10 accelerated to 2 meters per second squared. Let me put seconds, meters squared. So what will be our line on the y-axis for here is the velocity. So this one is going to be y is equals 2 times 10, which is 20 meters per second. So accelerated from 0 to 20 meters per second in 10 seconds. This is the line we have. In 10 seconds. This is 10. Yeah? This is 20 now. This one here, 10 seconds. And for that interval from 10 seconds to 50 seconds, it was doing constant acceleration. So if we have 10, 20, 30, 40, 50, 60, 70, 20, 30, 40, 50, 60, 70. From 10 to 50 here, it was doing constant acceleration. We are interpreting this graph, acceleration time graph, to velocity time graph. And then what did he do? From 50 seconds to 70 seconds, he slowed down his speed. He decelerated to -1. This time we have -1. Deceleration is -1. So we have again y all over x equals the gradient. In this case is -1. Decelerated for 50 to 70 is 20, eh? So x is 20 now. So y all over 20 equals -1. So therefore y equals -20. Yeah? So again, you're going to decelerate. Here. Here. This is deceleration. And what it's telling us, from here to here, it's 10. From here to here, it's 20. That will give us -1. So that's distance is now correct. So if they ask you to interpret the cyclist's motion, that's what we have done. And then they ask you to draw a velocity time graph. This is the velocity time graph of the cyclist. Yeah? And then you're asked to find, show the cyclist movement. Draw a velocity time graph to show the cyclist movement. Yeah, that's all. They don't ask us to find the distance, nothing like that. So that is it. Thank you for watching. These are simple problems. Thank you.